This is PreCalculus, Unit 4, Polar Coordinates and Functions, Lesson 2, Polar Equations. I have on the screen a polar graph, and I've got the angles marked off by multiples of pi over 6, or 30 degrees. Angles all expressed in radians. I've got an equation, a polar equation, r equals sine theta. I can tell it's a polar equation because the variables or the parameters are r and theta, not x and y. Okay, so r depends, r is the dependent variable in this case, theta is the independent variable, and I'm going to insert various values of theta to figure out what r is. All right, so we can create a graph by making a t-table, just like we do with a rectangular graph back when you first learned to do rectangular graphs. All right, so let's go ahead and get started here. I'm going to use green here. So theta is 0, so sine of 0 is 0. So I'm going to plot the point 0, 0, r theta, 0, 0. Note that it's r first and then theta, 0 degrees and 0 radius, 0 distance from the pole. Okay. Sine of pi over 6, you think in terms of the 30, 60, 90 triangle, that's 1/2. So 1/2, so when we put in pi over 6 for theta, we get out 1/2. So I'm going to treat this as 1/2, and this is 1, and this is 1 and 1/2. Okay. So 1/2 is going to take us right here. And this is 0 radius. Okay. Sine of pi over 3. Think in terms of the 30, 60, 90 standing up. The height is root 3 over 2. Which as a decimal is about 0.7 something. So go out to the pi over 3 radial. And go up 0.7 something. I'm going to go about 0.77. Okay. And then pi over 2, sine of pi over 2. Sine of pi over 2 is straight up and down. The sine is the height. That's 1. So at pi over 2, we have a height of 1. Sine of 2 pi over 3. 2 pi over 3, okay, think of our triangle here as root 3 over 2. So 0.77 or so. Okay, it might be bigger than 0.77. In fact, let me pull up Desmos. Root 3 over 2. Yeah, it's actually 0.86, 0.9, very close to 1. Okay, so as I thought, we were actually a bit off here. Okay, should have done a new layer here. Right, about like so. Okay, and sine of 5 pi over 6. Okay, again, reference angle 1/2. So 5 pi over 6 is 1/2. Back to sine of pi. That's 0. And notice we've come back where we were before. Okay, so far here's the shape we have traced. We've actually traced what appears to be a circle. Right about here. Let's see how close it is. You have to see how accurate my plotting was. Not very. But we've actually traced a circle whose bottom is at 0, 0, and that covers goes up on the y-axis. Okay, let's check. I'm going to change colors here so we can see here, and I'm going to check the next and see where it goes from here. What is sine of 7 pi over 6? Well, that's down here, so that's negative 1/2. So we go to the 7 pi over 6 direction, but we go backwards 1/2 right here. Right? Sine of 4 pi over 3, think in terms of this angle here, negative root 3 over 2, which is negative 0.86. So we're going to go to this direction, but we're going to go negative 0.9. Okay? And you can see it's retracing where we've been. 3 pi over 2. Okay? That's negative 1. So we face this direction, but we go opposite negative 1 right there. Okay? And then sine of 5 pi over 3. Okay, 5 pi over 3 is a 30, 60, 90. It's still negative root 3 over 2. Okay, so we're going this direction, but we go negative 0.87 there. And 11 pi over 6. Okay, think in terms of that pi over 6 angle, negative 1/2. So we're going to face this direction, but we're going to go the opposite direction 1/2. Okay, and then sine of 2 pi, which I won't put on there here, but is 0 again. And so as you can see, it repeats itself every pi. It traces that same circle. Traces the circle twice for going around the circle once, going around all the angles once. Okay, let's verify with Desmos. In Desmos, all I need to do here is really quite simple. R equals sine theta. Just type the word theta, and there you go. All right, and there's our graph. Pretty cool, isn't it? And so every graph can be graphed this way, and that's in fact what your calculator does. It simply plugs in values much quicker than you can and gets out values.